Good evening, everyone, and welcome to Getting Started with Intel Galileo Maker Sessions. My name is Matt Richardson. I'm a contributing editor for Make Magazine. Thank you so much for joining us. If this is your first time joining us, welcome. This has been a 3-week program all about getting teams of makers across the globe to build projects with Galileo, Intel's Arduino-compatible board featuring Intel architecture. Intel and Make have partnered up to equip teams of makers, 40 of them, with components and equipment, including the Galileo board itself, a bunch of different prototyping components, and a copy of the book Getting Started with Intel Galileo, and challenge them to create something with the board. Tonight is our third and final Hangout on air, our third and final session, and we tonight are doing a bit of a show and tell. We're showing projects and seeing what progress people have made. Tonight we've got a wonderful group of makers I'm about to introduce, and I want to let you know that if you have anything you want to ask or anything you want to contribute, please post that in the Google Plus community, and keep an eye on the Google Plus community as well for any kind of links that we talk about. So first, I'd like to start with our master makers. I've got Zach and Molmol from Yes, Yes, No. How you guys doing?
Good. Hey.
So you guys are calling in from Brooklyn, right?
Yep.
Tell us about Yes, Yes, No.
It's a Zach's joke.
Yeah, so we're a small studio, and our name Yes, Yes, No is the fact that we're 3 people, and 2 of us always say yes, and 1 person always says no, and we do interactive projects. We do installations and performances and things that involve projection and camera tracking and really sort of new forms of interaction. We've recently been doing a lot of hardware projects.
Zach liked to say we make magical things, magical projects, but I prefer to say that we build projects that makes people happy. So we build a lot of interactive objects that kind of surprise people in an unexpected ways.
That's great. And Yes, Yes, No, can you talk about that a little bit, the name?
Well, we're
No, we don't talk about that.
So, I mean, the other thing that we say about the name is that it's generally it's a lot of positivity, but like a little bit of critical. If you just say yes all the time, if you're not saying no, then you're not making the right decision. So you have to have you need a lot of yeses because you need to be positive, but you need some no's to make the right decisions.
Every time when I say no, I feel like I'm making the right decision.
Okay, good. We're gonna talk to you guys in a little bit about what your experience is with Galileo. I want to introduce everybody else as well. Next person I want to introduce is a friend and colleague of mine, Mike Sinisi. He's the executive editor of Make Magazine, calling in from Sebastopol, California. Hey, Mike.
Hey, Matt. Thanks for having me on the broadcast tonight.
Yeah, it's great to have you. Can you tell us a little bit about what you do for Make?
Sure. So, as executive editor, I help oversee the magazine, the website, and guide the tone and the content of Make. Got an amazing team of editors that really put together tremendous product. It's really it's just a ton of fun.
And what's going on there now today? Like what have you been working on lately?
Well, right now we are closing in on the finale or the finishing line of the next issue of Make Magazine, which will be our robotics issue. Should be available just towards the mid to end of May. So we are heads down. We're working hard to get all the articles finished up, get photos in the right places, get the names on the right articles. But we're also really excited because the current issue, our high-tech DIY issue, just hit newsstands. Is off to a great start. It's super fun. Lots of amazing things to build in there, and just a lot of things that the Galileo community can really get on board with and be part of as well.
Now, I myself have noticed that there's been a bit of a ramping up. I think because of the new format and the new the magazines are more frequent, aren't they?
They are. Yeah, this year, starting in January, we went from quarterly to bi-monthly. So there were 4 issues a year. throughout the history of Make Magazine, but now we're doing 6 issues a year, so 50% increase right there. And we also grew the magazine from that journal size to a full-size magazine. Our first issue in the, which is this guy right here, our first issue in the new size with the new frequency, our homegrown drones issue, absolutely destroyed all sales records that we'd ever set. So we're really thrilled about this. You know, we're off to a great start. And we just plan on continuing to bring all that make excellence that has been that we've been doing or trying to do throughout the years.
Great, and we have you on tonight to kind of give the editor's perspective and talk about what makes a project into a good material for the magazine or what makes a good documentation and stuff like that. So thank you for being here.
Yeah, you're welcome. And for the people who are working on stuff at home, go to makezine.com. Right there in the top nav bar, there's a contribute button. If you've got great ideas, projects, things you're working on, we're excited to hear about it.
Absolutely. Next, I want to introduce one of our makers, Barry from Carmel, Indiana. Hey, Barry, how you doing?
Hey, thanks for having me on. Good.
Yeah, sure thing. Tell us about yourself.
Well, I run a small company out here in Carmel called Manta Interactive, and we just make iOS, Android apps. We have a number of fun games in the App Store, and we also do really boring stuff for big business. But I guess I shouldn't say boring in public, I guess, because some of my clients might be listening. But and we've also integrated Arduinos into some of our projects, actually, which was kind of neat. And I've been building hacking since the early '80s, late '70s, ham radio, you name it. So again, Galileo's a pretty cool new toy for us to play with.
Great. Well, yeah, we'll talk about what you've been doing with it in just a little bit.
Okay.
Next, I want to introduce Joe from Lawrenceville, Georgia. Hey, Joe, how you doing?
Good. How are you?
Good. Good. Tell us about your space that you're in and everything.
We are Geek Space Gwinnett. We are a makerspace that opened only a few months ago. You might hear some people banging on a mill in the back. We're still kind of setting up. And we do pretty much everything people want to do.
So in the process of setting up, I'm sure things there are really, really busy. So we appreciate you joining us tonight for the Hangout on Air.
No problem. Glad to.
And next, I want to introduce Chuck from Tampa, Florida. Hey, Chuck, how you doing?
Hey, how's it going?
Good, good. Tell us about yourself.
Yeah, I'm an artist and maker in Tampa. Lately, last few years, I've gotten into noise circuits and musical kind of things, and it all started with Colin Cunningham's post on the Make blog about the Atari Punk console. For years, I had tried to get started in electronics, and I said, $10 and a trip to Radio Shack, and we'll see. And here I am years later, and lots of noise, lots of circuits, lots of solder fumes in the living room. But I work with a nonprofit here in Tampa. We're opening a maker space next month, and we also sponsor the local maker festival, MakerCon, which is this weekend. So this has been a real busy week between this hangout and the little hacks program with the Galileo and getting ready for our event. So I'm glad to be here.
Thanks for coming. Next, I want to introduce Neil. Neil, I'm not sure where you're from.
I'm also in Tampa, Florida. Chuck, I hope to see you at MakerCon this weekend.
Right on. Cool.
Tell us about yourself, Neil.
So, as far as robots and hardware hacking go, I'm just a hobbyist hacker and maker. Professionally, I developed software and hardware for human rights research. So I work a lot in Africa, Haiti, things like that. Mostly I work on large-scale population surveys, but in my free time, I like to build robots and gadgets, and mostly I hack with Arduino. I was really excited to play around with the Galileo.
Great. Well, thanks for joining us.
Sure.
So I want to first start off with Mole here. I met you this past weekend at Arduino Day at ITP in New York City, and this is when they had all these people coming together talking about Arduino. And you and Zach, you guys went up there and showed some of the work you did, and one of the things you talked about was a really cool Galileo project, and one of the first ones. Can you tell us about what you did?
Yeah, sure. I think we are the first artists that are invited, first group of artists that are invited to build something for Intel Galileo for their luncheon event at Rome Maker Faire. So we were very, very excited about the device. And of course we say yes, and they ask us what we want to build, and then we say, we want to build a robot. And they say, yeah, great. they're like, we want to see more like an Android robot gotten beat up by Intel robot. We're like, no, we don't really want to do that. We're kind of a non-violent group. So we want to build this really kind of cute and old school Japanese kind of style robot. They first contact us 3 weeks before World Maker Faire.
Wow.
And we received the first board. It's still they're still kind of testing and modifying things.
Yeah, I don't remember what rev it was because it wasn't the final color. It was a really early board.
It was maybe a black one.
Yeah, it was one of those.
A green one.
Yeah. I got one of these green ones. I didn't know what to do with it when I first got it. There was no instructions at all.
No, we really needed your book.
It was really, yeah, back then. Back in the day. So we have the latest version of the operating system for Galileo the Sunday before we're flying to Rome. So we pretty much did most of the development within a week.
Yeah.
So I want to let you know that if you think it's hard, it's really not that hard.
No, it's really
it's tough, but
yeah.
it's a really great experience. So we have some image and some videos to share, and it's also on our website on yesyesno.com.
Okay, great.
So we build a robot that goes around Rome Maker Faire venue and give away candies for kids. Yeah, let me do the screen share.
Great.
So we have like a batch of pictures.
Great, wonderful.
Yeah, and this is the type of story, Matt, that I just love hearing because it's, 3 weeks to go from nothing to candy distributing robot. Like, who doesn't want to get on board with something like that?
Absolutely. Oh, but
that's also one of the cool things with as these tools.
Yeah, it's really cool with Intel. They're just really okay with it.
Yeah, that's wonderful. So can you talk about some of the functionality of the robot and how it went over?
Can you see the pictures?
Yeah.
Yes.
Yeah, we can see them.
Okay.
Okay, so it has Galileo inside, and it works with kind of off the maker shelf motor controller that we have in the studio. We're using a SparkFun board, and we have another Arduino inside that controls the lights, and we have another Arduino inside that controls the servo motors, that kind of the candy dispensing system. And we're using an internet router, and all of the Arduinos are talking to Galileo via this router. And then we built an iPhone app. So it was more like a web app. We're using Galileo as a web server. So we're talking to Galileo via this app, and then we're able to control it and drive it around.
You want to show it?
Maybe let's see if we have some pictures from the inside. Sorry, that's the candy dispensing system. I don't.
Great.
So the story is we get to the Maker Faire the day before the big launch, the beginning of the Maker Faire, and then the Yes Bot was on the stage.
Yeah, actually, even to back up, looking at this robot in the pictures, it doesn't look that big, but it's really quite big, and we had to get it on an airplane, and that was our first challenge was to make it and to make it work, which was really, we could talk about some of the difficulties and what we did there.
And then as soon as we make it work, we have to disassemble the robot to put it in the box to bring it on the airplane with us.
Yeah, and this thing is like, we didn't really design it very properly for airplane travel. So It was pretty intense trying to get it on the plane and figure out how to get it to Italy. Then we got it to Italy.
And we assemble it again, and at first we were like the first Galileo project that works before everything happens. So we're very happy to be on the stage with the CEO of Intel, Brian. And the funny story is, it works, but it kind of works, but I have some problem with the motor controller, so it only turns to the right. It only turns one way.
It won't turn to the left.
And our mission is to show that this works so great, it controls the robot. Yeah. So we have to go from the right side of the stage, kind of right back of the stage, make a very steep turn, and then we go across the stage and then kind of dance around and give candies to CEO and Massimo from Arduino, and then come back off the stage. Yeah. And it was really a very kind of, it's not large, and then, you know, I was nervous. But then, so all the way, it goes all the way, and every time it has to turn, you just have to do a 360 spin.
Okay. Yeah, it's like the RC car I had as a kid. It only turned one way. You get used to it after a while.
Well, I fixed it after that, but it was a very kind of, so you know, it kind of like the robots kind of showing off. It like spins and dances around, and it takes longer for it to spin, so it stay on the stage much longer than other projects. That was a good part. And this is where the Intel Galileo stage is inside the Maker Faire. So we were really happy to be able to show the kids and give candies away. This is the inside. We use a water bottle as the kind of a candy container, and then we 3D printed the parts, connect them to servos, so it's like a dispenser door that opens and closes. And then we take it out to a Halloween party in Brooklyn after we come back. It was really fun, a lot of kids around, and it was like at least 50 kids around the robot every 10 minutes or so, and I stayed there for like an hour. And in the end, the candy was given away in the first 30 minutes, and the parents start yelling at me, kind of, you know, very anxious parents, because they're like, why did you not give my child the candies? What happened with the candy? I was like, it actually just like kind of running out, and I started to get really nervous.
Yeah, so you control the dispensing of the candy from the web interface. Is that right?
Yes.
Yeah, there's a web, so that the Galileo is serving like a web page. We're using Python, the Tornado framework. And then we created like a mobile. It's not a mobile app, but it's like a mobile-ready site. So there are some controls for piloting the Galileo, and of course there's a really big candy button, and then a button for saying.
Yeah, that's our 1 week very rough-looking app.
Hey, it looks really, really good, and impressive to get Tornado running on the Pi, you know, with very little documentation so early on. I know a lot of people have been wanting to get, you know, all kinds of web stuff running on the Galileo. Absolutely.
Yeah, the web, that was actually one of the most exciting parts from a development standpoint, is being able to have a command line and be able to run Python and be able to communicate with a running Arduino sketch. You know, that's exciting from a development, you know, process. And the Python stuff seemed to be the easiest. We didn't have, you know, one of the challenges with the Galileo when we were working with it is that there wasn't a package manager, and it wasn't, you know, we had built some of the stuff we had done already before with Node, and there was no way, we didn't have all of the, you know, basic tools to get all that stuff set up, but having Python there was really helpful, and, you know, the connection with Arduino went really quickly.
And also, it didn't have a lot of libraries that we are very used to in like Arduino. So Intel, and on this side of things, the Intel team was very, very supportive. I think that's how like our project get to happen, is that they're working overnight to write a servo library for the Galileo. Things like that.
They were in Ireland, and all I know is that every morning I would wake up and there'd be about 5 emails with
five versions
five versions of like firmware and all these instructions and all this stuff, and it was an amazing process because they, it was so brand new, and it's still brand new, so it's it's exciting to be part of something like that.
It's exciting, and it was a lot of fun working with the Intel team.
Yeah, so, my experience has been the same. They've been absolutely fantastic, providing help, and the community has been great. In the course of writing the book, I did run into a lot of questions and everything. It's been great. It's been cool to see a board really, start from really like raw and become, so developed. And it still has a bit of a way to go, but it's great to watch that process. Mike, you were going to say something?
Yeah, I was curious. On there was a photo of the web app, the controller that you guys designed for this, and I saw the candy button, I saw the directional controls, but there was the bottommost button. I was trying to figure out what that was.
Oh, that's a speaker, so it says different messages.
And
play sound effects.
Is that stuff that you had pre-programmed in there? What type of sound effects did you guys use?
Yeah, we pre-programmed. We would have liked to do, have if we had more time, maybe a text-to-speech or something a little bit more, advanced. But no, we had a set of audio.
Sound effects, like when it comes out, it goes like bling. Yeah. And originally, we wanted candy to just shoot out from the shoot out very far to the kids.
Yeah.
But we didn't do it. It's too dangerous.
Pretty dramatic.
Too dramatic.
And Marcella, who works with us in the studio, she found a really nice old tape cassette player that has one of those like drawers that opens up, like it's like a really nice kind of like smooth motion.
Yeah.
So she took the front face of that apart, and that's actually the thing that opens up for the candy is made from an old cassette player. So it has it's all like a very kind of 80s quality. And the other thing that's quite nice is we 3D printed the arms of the robot, and they're like these big sort of giant claws, and that was great. The prints came out great. It was a really nice process.
So I fried a few boards in the very beginning because we didn't really have hardware spec in the very beginning when they sent it to us. But if anybody,
what happened?
Sorry, what happened?
Ooh.
Yeah.
I plugged it into a 12 volts.
No, actually,
that'll do it.
But not only that, it was also plugged into my laptop at the same time.
At the same time.
So there was a moment where it like we smelled it, and it smelled like burnt electronics, and I was like, oh, that I was like, I love that smell, but then I realized it was my laptop also that was making the smell. So that was a tough moment.
And then I emailed them right away. I was like, what happened? And they're like, probably shouldn't plug in the 12 volt.
Yeah.
But then because we have to make the robot mobile, so we're using 2 12 volt batteries inside the robot. I'm actually using 3. So if anybody is trying to kind of get it mobile going, then we have a lot to talk about to show you.
Yeah. Great. Thank you. That's great. I'd love for you guys to stick around and see the rest of the projects as well, but I appreciate you telling us about your experience with creating the Yes Yes bot. I want to also bring in some of our teams now. Barry, can you tell us about what you did with Galileo?
Well, sure. Actually, I'm kind of late to the game compared to Yes Yes No. My Galileo arrived less than 2 weeks ago. I started playing with it, and I was actually more interested in the software side of this, and how the Arduino part I assumed would work fairly well with some of the existing hardware, and there were some ups and downs there. Some of it did, some of it didn't. But I really wanted to see how you have what I call the Arduino side versus the Linux side or the Galileo side, how they communicate with each other. Matt, your book was a great help there. And
Thank you.
I was stumbling a little bit and got the book, and it really helped quite a bit. So what we did is had the Linux side communicating with for the first test here, communicating with a Weather Underground to get weather data from my location. So there was that calls a simple JSON API and parses the data in Python, and then we send that. Then we actually I write the data to a file on the Linux side, and then the Arduino sketch that's running actually then goes and keeps reading that file. So it's on its own loop, reading that whatever's in that file, and then that as that file gets updated, you'll see the changes occur on the Arduino. So I'm going to actually switch over here. I'm going to take a second for my camera to stabilize. So you should be seeing the project, and it's a rather crude board. It's actually just one of my wired up things. I didn't have this one on an actual shield. But you should, I don't know if you can see that, but it's showing.
Yeah, we see it great.
Yeah, our current temperature, nice cool Indiana day, 51.8 degrees with a barometric pressure of 29.74 and falling, which probably means more rain is on the way. So it's actually rather straightforward. So what happens is the Python script is running in a loop, and every 10 minutes it actually makes the call back to the server. All right, and then every 10 seconds the Arduino is checking the update of that file. So not much is happening here. Right. So what I decided to do then this afternoon, in the minutes prior to this hangout, was to see what I could do with an iPhone app. So I wrote another Python script that communicates with a nice web service called parse.com, offered by parse.com, which really you can think of it as a hosted database with really, really good APIs to communicate with it. And it was originally optimized for use with mobile devices. They have very strong software development kits with mobile devices. But they also offer up a very good REST-based API, which allows things like Galileo to communicate with it. So so now I've got, I'm going to actually turn, on Galileo now, I'm actually SSH'd into it. I'm going to switch over. It's actually switching now. So now the new program is running. So in a second here, you should probably see that it's the same Arduino sketch. It's still communicating the same way. So hopefully any second now, you will see some changes occur. And as any live demo goes, it probably won't work, but we'll see.
So the Arduino sketch is really just kind of playing dumb and just doing what Python tells it to do?
No, actually, all the Arduino sketch does is it reads the contents of two different files. And one of the files it presents on the first line of the display, and the second file displays on the second line of the display.
I see.
All right, so it's dumb in that it's doing that single purpose, but as long as you feed the data to those files on the on the Linux side, you'll see the output. So I don't know if we can see this. This might be a little rough. So I have a simple app written here. This is a little native iOS app, and what I'm doing is I'm going to send a message, hello make. We're going to send that now, and that actually put that message up on the parse server. All right. Now at the same time, in a few seconds, we should see the Arduino side. There comes the message in. All right. So now we have the message that just came in from the
oh, wow.
Galileo. Then communicated with that, got the same data out of the database, and is now presenting it back. So the idea here is, this is stuff that Arduino is it's very hard to do with just an Arduino. You generally have to have other support. Now it's a dunk shot to do with Galileo, and yet a lot of your existing Arduino components can still work. So there's no real specific application for it yet, but from a software perspective, we now understand how that data flow might work.
Yeah, absolutely, and I see Parse as an incredible resource for makers to be able to quickly stash data online and fetch it from any kind of connected device that they create. Is there a free tier for that service?
Yes, there is. In fact, that's what we're using here. Again, it's like so many of these things where you go up to a certain amount of usage before you have to start paying. It really, if you're a seasoned developer, it's a real dunk shot to get going because they've presented a very nice API. And if you're anybody who's done any work with any kind of REST-based APIs, it's also very intuitive. So it was nice that we worked on both, and I was very pleased with how quick we were able to get that running without any change to the distribution on the Galileo to get that data across.
That's fantastic.
Yeah.
So Barry, what's with this project? What's next? Where are you going to take it?
Okay. Well, probably the next thing is work on the Arduino side to get some of our existing shields working. And one of our next projects that my team at Manta Interactive, we love playing with things on the side. So we've talked about doing putting an IR transmitter on and just using it to control televisions next. Change stations. Since we have amounts to a very complete computer we can deal with. So that might be next. And again, fully understanding the capabilities of the Linux side.
Very cool. That's awesome.
Yeah, that's fantastic. So, and can you talk about a little bit about the I found that like when I was only using Arduino, I had trouble doing what I wanted to do, especially when it came to connecting to APIs and connecting to any kind of web service. There's a lot of work there. Can you talk about like how Python helps in that situation?
Yeah, well, one, big memory footprint. So Arduino is very limited on memory, so there's only so much you actually can do. So if you're taking up most of your Arduino space just parsing through what could end up being a very large data set coming back from your service. You have to have the overhead of writing the parser, storing the parser, bring the data back, and having that happen using standard libraries. So on the Python side, I just used the straight up JSON libraries and the straight up HTML libraries already existing, just dropped right in. And also, of course, all the network connectivity. There's a number of ways you can get Arduinos to talk on the network. None of them are really clean and easy. And so by having that side, it's just like almost like programming any other device, any other computer, right? You can just get there a lot faster.
Yeah, I remember. Go ahead.
Yeah, you can think of also in terms of threading. Virtually a Arduino is a single-threaded device. So you have the one loop. Everything goes through that loop. So what going 100 is virtually you can think of the Linux side doing its thing like it's doing right now. It's sitting there spinning around, checking parse for updates, and there's another run loop inside the Arduino side running. All right, so you get even though I'm not actually sure the internal architecture of the Galileo, but a lot more simultaneous behavior.
Yeah, absolutely. Yeah. Thanks for sharing that. I want to move over to Chuck in Tampa. Chuck, are you there?
Yeah, hi, how's it going?
Good. Tell us about what you did with Galileo.
Well, let me start off by saying I'm a total noob for microprocessors. Usually I'm the builder, tool guy in these things, and I got a buddy that does the programming, but with everything going on, we had scheduling problems, so Saturday morning I loaded the Blink sketch, so that's where I started. So all this is just like a few days worth of cramming. Anyway, I built a laser projector. Basically, it works like a spirograph. I wanted to control 4 fan motors with mirrors that were slightly offset and shoot a laser through them. And by controlling the speeds, you generate these really cool patterns. Probably should have started off learning the specs of the device and what was possible before I started with the prototyping the idea, because the motor shield wasn't compatible with the Galileo, at least not at my experience level. So that was the first strike. So I decided, okay, we'll use the Arduino to control the motors for the laser projector. So I got that up and running, and that was cool. And then, I want to use the Galileo. So let me maybe I'll incorporate, since I'm a noise synth kind of guy. And so let's incorporate some kind of simple sound program. Well, the Galileo wouldn't read most of the libraries that relate to sound creation and synthesis. So I ended up incorporating that into the sketch on the Arduino.
Okay.
Not wanting to build something that completely didn't, ignore the Galileo. One of the things is that the motor shield uses analog, 4 and 5. So that leaves you with 4 analog input-output. I wanted to control 4 motors, but I also wanted to control the blink rate of my laser. So I basically loaded up the basic blink sketch with the analog read and use the Galileo to control the blink rate of my laser. And everything else is Arduino. So there you go. At least it's incorporated in some way. I had a lot of fun with this build. Let me tell you, it was a few late nights of trying things, but one of the things about the maker scene that's amazing is, I'm 42 and I started this stuff pre-internet, making and tinkering, and it's so nice to at 3 o'clock in the morning run into a problem, hit the Arduino boards, hit the project I posted a couple times where I had problems and people suggested, well, try this, try that. It is so streamlined to go from zero to project in a few days that just wasn't possible back in the 80s. And the community is amazing for that.
Yeah, absolutely. Absolutely. That's the same for me. I wouldn't have been able to do what I do without the community and all the resources that are out there now. I tried as a kid. I tried as a kid to get into this stuff, and yeah, it just wasn't out there. Can you show us the laser going?
Yeah, I'm gonna move the camera, so we're gonna go handheld.
Okay. All right. Yeah.
Okay. Let me shift my light. I'm gonna show you first what we got here. This is all recycled and repurposed materials that was laying around the shop. So down here we have 4. Are we getting a good view of this? Okay.
Yeah, just hold the camera steady for any of the shots you want us to see, as steady as you can. There, yeah, we can see that.
We got 4 fan motors, DC 12 volt, mounted. The laser is right in here, so the laser bounces from here to this one, and then out. As you can see up here, we got our Arduino and our Galileo laser blinker. So I'm going to go ahead and close this up, and we'll get it turned on, and we can see what it does.
Okay, I can see the laser beam there against the wall.
Let's see, get that aimed somewhere pretty good. Okay. Now we're going to turn on our power strip, and voila. Now this is with the laser on constantly. Got a switch there that gives us a nice little blink. And by playing with that right, I'm going to turn up a few of these motors. There we go.
Oh, there you go.
So basically, you got something like this. You turn the blink on, and it just gives you these different breakup patterns here. How about that? There we go.
Oh, yeah.
So just by adjusting multiple motors and just playing with it, it gets a lot of really cool patterns. There's a little vibration issue there that we still have to work out. And so the other side of it is, since I am a noise guy, I said, why don't we make a synth that goes along with it? And I explored some of the libraries out there. I ended up just loading up the Arduino sketch that I found. It seems to be pretty popular. It's a good place to start. So
there we go.
Yes.
That's looking great.
Yeah. So Chuck,
it's
the
fun,
audio is the audio something you're controlling, or is it being generated along with the different random patterning of the laser?
The audio is controlled by 4 pots on the top. I'll lift this back up, and you can see I've got this controls this knob. This pot here is controlling the rate of the laser when it blinks. And these 4 are controlling the parameters of the synth, and this one is volume. And this switch just basically turns the audio on and off, and this switch controls whether or not the laser is blinking or on solid.
So you put this whole thing into a nice enclosure. It's something you could take out, and this is your party machine to go. That's really cool.
And let me say about this enclosure. My wife works in the cosmetics industry, and retail is one of the most wasteful businesses out there. Every 6 months, every 3 months, they're getting new displays. This was actually a makeup display, this acrylic box that I kind of fashioned into this. And I want to take this opportunity. I'm going to move my camera back up here. I want to take this opportunity. I want to show you. Take a look around this living room. This is our living room. Is a workshop, and That is the most tolerant woman in the world to put up with the smell of the fumes of the solder and the noises at 4 o'clock in the morning when I have a revelation on a circuit. So behind every maker is a really, really tolerant partner.
Yeah, that's great.
She has our respect.
What?
You have our respect.
You know, I'm also seeing a theme of reuse here. You know, a lot of these projects here, you know, it's the cassette tape player opening, and that's fantastic. It's one of my favorite things is when you can bring new life to something old. That's great.
I'm totally a trash hound. I was dumpster diving in high school. It's amazing the bounty of what's wasted in this country, and if I can avoid a trip to Radio Shack, by all means, I'm scavenging whatever I can. Actually, the first year of my electronics, I hardly bought any components. I bought a heat gun and a putty knife and picked up every circuit board I found and pulled resistors, capacitors, transistors. Everything was reused. The only thing I bought was like ICs, and those are a little bit harder to get out of the circuit board, but I pull out resistors out of my box, and I'm like, oh, that one's got solder all over it. Let's use a new one now. A little bit. I can afford to do bulk orders from China.
That's great. That's absolutely wonderful. I want to jump over now. Thank you so much for showing that to us. That's absolutely fantastic. It's great to see how quickly you also did that. It was so fast how you pulled that together. I want to jump over to Neil. Neil, are you there? Did I lose you? Did I lose everybody?
I'm here, Matt. We can talk.
Oh, all right. I see everyone down below is frozen, but now okay. Well, we'll try to get Neil in a bit. Momo, what would you say if someone is getting you're just getting started with Intel Galileo? What would you say is a good tip for them?
When I started with Galileo, I kind of tried every tricks that I would try with an Arduino. And that was when I didn't really realize the difference because I didn't really have the hardware specs. So that was kind of my first step, and then I realized what needs to be improved and what doesn't it have and what does it have. And I would say we will try to put most of our documentation online really quickly, because I think what we go through is kind of this very painful process will be very helpful for most people.
I mean, for me, it was the socket connection. I don't know how you recommend people to do, in your book, how you recommend the connection between, the sort of Linux world and the Arduino world. But for me, it was that first moment when I opened up a socket was really exciting. And I had an ability to send data from, in one direction or another. That was exciting because, I know my way around the command line. I can, write a, I know enough Python to get into trouble. Sometimes I don't know how to get myself out of trouble, but, the moment that I got those things talking with, also as we saw in the first demo, like it's, get these things talking, there's a lot of interesting possibilities.
Just get it to blink an LED. It was like, yes, it works. That was a moment.
Yeah, absolutely. Yeah, a couple people have mentioned. It's a show and tell show, and a couple people have already mentioned the project that I have been working on, and it's finally officially done because I got it physically in my hands just yesterday. Last night I came home to getting started with Intel Galileo in print. Thank you. This has been out in digital form for a few months, and a lot of people who have been amazing at giving feedback, who have Galileo, have been trying different things. What's wonderful about publishing these days is that people out there can do, you can send it out digitally to so many people, and we can quickly revise and make fixes, and then before you know it, you have a very well-edited book with a lot of people who helped make that happen. So this is the Galileo project that I have been working on myself. So I'm glad to see it's out there and should be shipping from all over the world now, hopefully very soon. So, and if you do get a copy of it, I'd love to hear what you think of it, because I can incorporate all the feedback into future editions. We have a very fast ability to make changes and put them into future editions really quickly. So that's my show and tell for tonight. Getting started with Intel Galileo.
And it was a lifesaver for me.
I'm glad to hear it. I'm really glad to heir it. So we're having trouble connecting with the rest of our makers. We dropped Neil and Joe. So we'll give them a moment to try to get back in. Otherwise, we can just kind of shoot the breeze a bit about Galileo. Mike, we get a lot of boards. We see a lot of boards coming through. And you see what people are responding to. What are people like out there clamoring for? What are they looking for? What kind of projects do they want to do when they see all these boards? Where do they turn? What do they do?
So there's a lot of stuff that comes through. It's one of our core areas that we really look at. Microprocessors. The Arduino revolution has really been a fascinating thing that make readers have become a big part of. But with all the boards from all sides, it's just amazing because they've all developed with like a singular idea, like an educational board. And now people are taking them, and we've seen the 3D printers have become available and viable because of things that people can do with microprocessors. Quadcopters are becoming super common, and they're all running Arduino architecture inside of them. So the things that people are doing that are surprising new things that are just exciting. Kind of like our yes no people there. Like just fun stuff that excites people and surprises them. We had a really great project on the site a couple weeks ago. The NASA Mission Control Desk. It had a mixture of Arduino, Raspberry Pi components in it. His father built it with his son, sort of a replica NASA mission control board that was his workstation for doing homework, and then he flips the whole thing open, and on the inside he's got all the knobs and controllers and buttons and lights, and it's just, you can do this stuff now. You can build these things and you can make incredible things happen. Our boards issue, this is issue 36, came out at the end of last year. Our last issue in the small size really steps through the entirety of what we look at in the boards universe. It's got a great glossary section as well. Thanks for writing that, Matt.
Thank you.
Yeah, but I think the thing, to answer the question, it's just there's so many surprising things that just keep popping up. Things that most people aren't imagining are possible, and then suddenly something shows up that we had never really thought about or expected before. And it's because the software is, these libraries are massive, and the community is massive, and they're all contributing, and the boards are becoming easier and easier to use. Galileo having web app capabilities built into it just really only opens things up that much more.
Yeah, it's really exciting, and there are there have been boards out there that have run Linux, and this is the first time when I started with Galileo. This is the first time I really saw one that had this really strong Arduino compatibility out of the box. Everything was totally familiar to me. It was fantastic. And that's great. Now, so I think we have Neil. Neil, can you hear us all right? Are you there?
Yes. It took 5 minutes to unmute my microphone the way it goes.
Can you show us what you built with Galileo, please?
Sure, I'd be happy to.
Great.
So I'm going to show you my project, which is a work in progress. And I should mention that I'm also representing the fabulous Hendrick Brothers hacking and making team. The other guys are not here right now, but it's other folks' work too. So I'm going to adjust my camera so you can see what I'm working on. And what this is a kind of little robot. It's called a data monster, and the design comes from a guy named Lucas Ainsworth, who actually works at Intel, and the data monster was one of the early things that was put forth as an example of what you could do. So I wanted to build a data monster and then add some other things on. So I'll show you where it is now, and then maybe tell you what I'm gonna end up with. Okay?
Great.
So if you can see here, it is essentially a kind of robot arm, and it has a couple different degrees of freedom here, and it's really just 5 servos and a bunch of laser cut pieces of wood, and it's held together with glue. The whole thing is glued together, to be completely honest. So it's a kind of very interesting carpentry project for something that's very high tech. It actually involves a significant amount of carpentry, and the body of it was I actually had it cut at Pinoco. So I sent in an order, and they sent me 1 sheet. So every piece that you see here on this robot actually fits on a single sheet, and then you get this kind of woggly robot arm that can turn all different ways. Okay, and then the electronics, it has a wiring harness that just connects all of the servos, and in the front of it, it has some sensors, and these are infrared distance sensors. They could probably be replaced with ultrasonic sensors, and I think that would be an improvement, but it's got these guys right now. And then in the front, you can see it's got the Galileo, which will control all of the mechatronics. So the idea behind this guy is that he's meant to be a kind of emotive robot. He's meant to react in an emotional way to the environment around him. And so he takes in stimulus, and then he has a series of basically macros that control his movements that will show things like, like he can be curious. Oh, pop that off there. He can be curious, or he can be like funny, or show sadness or laughter. The kind of thing we're going for is like R2-D2, that even though he has no words or anything, his movements, and I could put a speaker on him and add some whistling and things like this, but this will indicate his emotional state. And so then it's only a matter of what is the intake, like what is he reacting to? And the Lucas Ainsworth example that he's run at a couple maker fairs has it interact through these distance sensors, so that when it detects a person being close to it, it wants to interact with that person and wave at that person and things like that. But I thought an interesting thing for it to do would be to participate in my love of stupid television shows, movies. And so I'm going to add to this, as a shield on top of the Galileo, a video experimenter shield from Nootropic Design, which I think Matt Richardson will be familiar with.
Yes, I am. I love that
shield. It
shield.
allows you to actually... Yeah, right? Okay, I saw that wonderful project captioning, and I thought an interesting thing that's in closing are the things that they put in there for people who are deaf. Say there is emotional music, gunshot, special effects. And those things are held in brackets. So I figured it would be yeah, exactly. Thank you, Matt. Yeah. So that thing allows you to peel off the closed captioning from whatever television show you're watching. And then if it's a gunshot, this guy can go, oh no, it's a gunshot, and hide his little pointy head. Or if the thing says laughter, he can laugh along with you. So I want him to watch TV with me and laugh along with me and be scared along with me and things like this. And I can see it eventually being kind of annoying, but I think it's funny. Yeah.
That's absolutely fantastic.
So yeah,
I love that.
That's the project.
That's great.
Yeah.
I love the direction that you're taking that in, where you've got this. It's like an automaton puppet that is reacting to really like organic things. It's not just that's tough to do, and that would be really, really cool. I can't wait to see that.
Yeah, Neil, that is.
I'll be sure to
exciting.
keep you posted.
Great. Great. Cool. Oh, and we just dropped off. I got to thank Neil for that. Thank you very much, Neil, for being on. I'm glad we were able to get him in. And sorry, the connection was a little choppy there, but we did get a good idea of what that was all about. He was talking about the video experimenter shield there, which it lets you do all kinds of great things with video. Not only read the closed captioning information, but also you can do some simple overlays and some simple graphical stuff with Arduino. It's a fantastic thing. We're running low on time here. Actually, I can't believe we've been going now. We've been talking about Galileo for a long time. I want to open it up before we get out of here. Is anyone want to share anything else before we go?
Yeah, I think there's a really helpful things for us was that the Intel team is always just kind of be there for us because they're very excited about the Galileo. And so I would really say if you really run into hard problems that you don't really know anybody can solve, just write them an email. Yeah,
absolutely. Yeah, if you run into a problem, don't just give up. If you put the problem out there, there's so many people who can help you. It's a great point. Anything else out there?
Yeah, Matt. One thing I wanted to say is thanks to everybody who's been contributing into the Galileo community on our Google Plus page here. There's some really incredible projects that are underway, and some of them even wrapping up. Joe Ratolsky's door lock, the Kevin Gagnon's his spinner bot. Jay Peace has a great thing that he worked on with his son. Doing a Beyblade launcher, which my nephews definitely need me to. They want me to build that for them right now as well. So great stuff, really cool stuff. It's a great community, and everybody's really gotten into it. So if you guys are looking for more Galileo stuff to get inspired by, make sure to check out the community page.
Absolutely, yeah. Even though this is the last Maker session that we're having over Hangout on Air, the program continues on the Google Plus community where you can interact with other makers. So definitely keep sharing. And I know a lot of people are still in the midst of their Galileo projects, and keep sharing, and Make editors will be watching that. So yeah, a huge thank you to all the makers. I want to thank all our guests tonight for being here. Thank you so much. I know it can be tough with the connection troubles, but I had a great time talking to all of you about what you were doing with Galileo. So thank you so much for being here.
Thanks.
Yeah.
Thanks.
Thank you too, Matt.
Thank you.
Yeah, thank you. And on behalf of Make Magazine, I want to thank all our friends at Intel for helping to make this whole program happen. And again, thank you to all the participants. Please keep participating on the Google Plus community, and please keep showing us what you're making. In the meantime, have a good night. Bye.
Ciao.